Hi everyone, Miss Potts here, and I hope that you're ready for another lesson. So let's go ahead and take a look at our focus. Our focus for today's lesson is to find and estimate square roots and to classify numbers as rational or irrational. The questions that you should be able to answer by the end of this lesson are: what is the square root of a given number? And what classifies a number as being rational or irrational? So I want to start by talking about square roots and squares. You've heard of the terms inverse operations, how addition and subtraction are inverse operations. Multiplication and division are inverse operations. Well, so are square roots and squares. They're inverse operations, so they undo one another. Let's go ahead and talk about squares, perfect squares. A perfect square is a number that is the square of a whole number. When we talk about a perfect square, I really want you to envision a square. So if you have a square that is 2 squared, 2 by 2, there's 4 pieces inside. Or a square that's 3 by 3, it has 9 pieces inside. There are no missing pieces, so it's a perfect square. It makes up an entire square. If you are trying to figure out the square or the square root of any value that isn't listed here, then it's not a perfect square. There's a piece missing somewhere, or some pieces. Let's go ahead and talk about square roots. Whoops. A square root is another number that when multiplied by itself is equal to that given number. So the square root of 9 is 3, because when we multiply this given number by itself, 3 times 3 equals 9. How they're inverse operations. 9, the square root of 9 is 3. That's the number multiplied by itself twice to equal that perfect square. So let's talk about irrational numbers. Irrational numbers, it's a number that cannot be written as a ratio of 2 integers. So some examples are pi, 3.14, and it keeps going on and on and on. It's a repeating decimal. Same thing with this example we have here. Rational numbers are any number written as a quotient where two integers where the denominator is 0. So here's some examples. -3, 0, -1/2, 1.2. And I think that you guys will be able to distinguish between the difference between irrational and rational numbers with this chart. So go ahead and write this down. You can pause this video if you need to, but this chart would be very helpful, I would think, for classifying real numbers. A rational number as a decimal will terminate, or in other words, end, or it repeats. As a decimal, as for an irrational number, it never terminates or repeats. It just keeps going on and on and on. So go ahead and pause this video, write this down, and then we will continue. In our first example, we're asked to find the 2 square roots of 16. So what numbers multiplied together equal 16? Well, obviously 4, because 4 times 4 is equal to 16. So that's one square root. Another square root is -4, because -4 times -4. 2 negatives multiplied together equals a positive 16. So, in short, the 2 square roots of 16 are 4 and -4. Let's go ahead and take a look at some more examples of finding square roots of values. We have to find the square root of 36. What is the square root of 36? Well, there's two numbers, 6 and -6. Because 6 times 6 equals 36, and -6 times -6 also equals 36. Now we're asked to find the square roots of 1 over 49. Don't let this fraction confuse you. Keep the numerator the same. What number times itself equals 49? 7. So 1/7 times 1/7 is equal to 1 over 49, and the same with negative 1/7. And now what is the square roots of 9? 3 and negative 3. Here's a little reminder when estimating square roots. To estimate the square root of a number that is not a perfect square, you're going to use square roots of the nearest perfect square. So let's go ahead and take a look at what that looks like. And in an example, we have to estimate the value of the square root of 39 to the nearest integer. Well, let's go back to our perfect square chart. Perfect squares, we have the square root of 36 and the square root of 49. So 38 would fit in there. So let's go ahead and use that information on our slide. We're going to put this on a number line. And so we have the square root of 36. And the square roots of 36 are 6 and negative 6. When multiplied by each other, by itself, it's going to equal that perfect square. The other perfect square that we discussed was the square root of 49. So what number multiplied by itself will equal 49? That would be 7 and negative 7. But we're asked to estimate the value of the square root of 38. 38 on this number line would probably land right here. So is the square root of 38 closer to the square root of 36? Absolutely. So as an integer, we would say that the square root of 38 is approximately equal to 6 or negative 6. Now that we are to the end of our lesson, let's see if you can answer these questions that I proposed to you at the beginning of the lesson. What is the square root of a given number? And what classifies a number as being rational or irrational? If you have any questions regarding this lesson, please don't hesitate to let me know. Don't forget to complete your assignment for this lesson as well. Bye guys, see you in class.